we were required to obtain information of corner bridge power station. For the task distribution, I will do the part of introduction, the power consumed by the pumps, fans, and other auxiliary equipment. And then Luke will explain about the net power output, the type and amount of fuel. Then Aina Nabila will explain about the rate of heat rejection at the condenser. And lastly, Elisa will take part in the rate of entropy generation and conclusion. A corner bridge power station is a combined cycle and open cycle which has 4 gas turbines power station located near Kampung Jawa in Kelang, Selangor, Malaysia. All natural gas plants use a gas turbine. Natural gas is added along with a stream of air which combusts and expands through this turbine, causing a generator to spin a magnet, making electricity. There is waste heat that comes from this process because of the second law of thermodynamics. So, what is gas turbine system? A gas turbine is a combustion engine at the heart of a power plant that can convert natural gas or other liquid fuels to mechanical energy. This energy then drives a generator that produces the electrical energy that moves along power lines to home and businesses. Turbines has 3 main parts, which is air compressor, combustion chamber, and lastly turbine.
Hello, today me, Lau Hong Lim, would like to discuss on the net power output of the corner bridge power plant. Net output power is net electricity transmitted from a power plant to grid, subtracting electricity used in the plant by auxiliaries such as fans, pumps, flue gas treatment systems, air conditioning, and lighting, also called house power. Corner Bridge Power Plant has an installed generation capacity of 895 megawatts, where the capacity means the maximum output power of the power plant under specific condition of full load. The power normally is produced through a combined cycle block producing 315 megawatt, which is as shown in the first diagram, and 4 GT13E1 open cycle gas turbines of 130 megawatt each. Therefore, the net power output is the sum of the power producing by the combined cycle block and the open cycle gas turbines, which is 315 megawatt plus 4 times 130 megawatt, which is equals to the 835 megawatt. The second topic I want to discuss is the type of fuel and the amount of fuel used. The type of fuel used by the Corner Bridge Power Plant is the natural gas. According to Malaysia Energy Statistic Handbook 2020 by Subrajaya Tenaga, 0.9479 MMBTU is used to produce 1 gigajoule of electrical energy. For the power plant to work for 1 hour, the unit generated is 835 megawatt hour, which is equals to 3.006 terajoule. To produce this much amount of electrical energy, the amount of fuel needed is 2,849.1383 MMBTU, and convert to the normal cubic meter is 77,885.4. So, which means that to produce for the Corner Bridge Power Plant to produce 800 megawatt for 1 hour, the amount of fuel needed is 77,885.4 cubic meter.
Next, what is power consumed? In electrical engineering, power consumption refers to the electrical energy per unit time supplied to operate something such as a home appliance. Power consumption is usually measured in units of watts or kilowatts. The energy used by equipment is always more than the energy really needed. The main items of the electrical power plant are alternators, exciters, transformers, regulating equipment, bus bars, reactors, switching equipment, protective equipment, batteries, and carrier current equipment. Power consumed by the pumps, fans, and other auxiliary equipment. As we know, auxiliary consumption means the total electricity consumed internally within the boundary of a power station to run the plant. Net output power is net electricity transmitted from a power plant to a grid, subtracting electricity used in the plant by auxiliaries such as fans, pumps, fluid, gas treatment system, air conditioning, and lighting, so-called house power. A standard 500 megawatt coal power plant produces 3.5 billion kilowatt hour per year. As I explained in the previous video, this is how is power generated from the gas.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aina Nabila binti Zaini. My ID number MA20144. Okay, in this video, I will explain about the rate of heat rejection at the condenser in general. Next slide, I will explain about what is heat rejection. Okay, the heat rejection is the excess heat from a cooling system and starts when the cooling tower heat load in reaches. Heat rejection is the total amount of heat energy which is transferred from the cool side to the warm side, plus the work carried out by the compressor. Okay, next I will explain what is a condenser. Condenser is a necessary component of the steam cycle as it converts the steam into water. Okay, for boiler feed water, a condenser serves the following purpose: 3 maintains a very low bed pressure on the exhaust side of the turbine. Next slide, the condenser used in power plant and gas power plant. What is temperature that can generally use? Okay, for generally concept, the condensing temperature is the temperature at which the refrigerant gas will condense to a liquid at a given pressure. Okay, a air-cooled condenser normally requires between 125 degree Fahrenheit to 113 degree Fahrenheit condensing temperature to reject heat to 100 degree ambient. Okay, next, how do you find the heat of rejection? Okay, total heat of rejection in bracket THR is equal to net refrigeration effect in bracket RE at the evaporator compressor capacity plus the energy input into the refrigerant by the compressor heat of compression. Okay, this is the formula. Okay, RE is the refrigeration effect or the compressor capacity in BTUH. Okay, 3414 is equivalent of 1 kilowatt. If you don't know the compressor energy consumption, THR equal to RE multiply heat rejection factor. I think that's all from my parts. Thank you for watching my presentation slide.
ID number MA19089. The entropy generation rate is associated with the losses in a process. An entropy volume balance equation can be defined as follow this equation. Okay. The first one, do turbines generate entropy? Okay. Turbines, compressor, and jet nozzles are all included in this category of equipment. Turbine adiabatic efficiency is measured as follow. For the first one is for the Janine turbine. The second one is entropy will constantly increase. Okay, the next one. Okay. Is it possible for the entropy change to be negative? Okay. For example, a closed system's entropy constantly goes up as it is reduced. Open systems entropy change may be negative, but because of the entropy of the other system is positive, the total entropy change in this system is also negative. The last one is, do you think that entropy is a negative or positive quantity? There is no net change in entropy if the process is reversible. For this reason, if it's positive when we see a growth in entropy in an irreversible process, the general entropy of the cosmos is rising at an accelerating rate. A power plant's net power output is estimated by deducting the electricity consumed by auxiliaries such as fans, pumps, and flue gas treatment equipment. Mercury has an installed generation capacity of 895 MW, where capacity refers to the power plant's maximum output power under particular condition or at full load. Of fuel is required to generate 835 MW for 1 hour. After subtracting the electricity consumed in the power plant by auxiliary equipment, net output power is the amount of electricity supplied from a power plant to the grid. Thank you.